Hello and welcome to section 6.6. Before we get to 6.6, here are the answers for the extension 6.5 graphing absolute value equations. Alright, 6.6 we're going to be working with absolute value inequalities today. So most of what we've been doing in this chapter has been inequalities. And then yesterday, or 2 days ago, we worked with equations. But everything else has been inequalities. So what we're going to do today is we're going to combine what we've been dealing with inequalities and the absolute value equation. So this is kind of the pinnacle of the chapter. Okay, so we have the absolute value of x equals 3. The distance that a number is from 0 has to be 3. The answer was 3 or negative 3. What we're going to be doing today is the absolute value of x is less than 3. What this says is the distance that some number is has to be smaller than 3 units. Or the distance that x is from 0, some number is from 0 has to be more than 3. So what this looks like here, all of the numbers in this range here from negative 3 to 3, if you pick any number within that range, it's going to have a distance from 0 smaller than 3. Now this one here, all of these numbers greater than 3, 4, 5, 6, 7, all those numbers have a distance from 0 more than 3. Or all of these numbers here have a distance from 0 more than 3. So hopefully you recognize these types of graphs. That is an intersection, it's an and statement. And this is a union, it is an or statement. So there's a little bit of tie-in to compound inequalities. Alright, so there you go. That's just what I graphed up there. It just looks a little bit nicer. Alright, so solve and graph this equation. First, let's say it in words. What this means, the distance that some numbers from 0 has to be 6 or larger. So on a number line, what that looks like are these numbers right here. 6 or larger. And it's also these numbers right here. So you have to use the word or. Now this says smaller than half. Smaller than 0.5. Okay, so the distance from 0 has to be smaller than 1/2. Okay, so that would be smaller than or equal to, that would be right there and right there. So these numbers here, and then these numbers here. Now because it's an intersection, you can write it as one compound inequality versus the two separate ones with the word or. So here we have to use or, here we can just write it as one statement. Alright, now we're actually going to work with some more difficult ones. The first thing you're going to do is it and or? And since it says greater than, I'm going to draw a picture. The first thing, first draw a picture. Always draw a picture. This is what I expect you guys to do in your homework. So 0, 7, negative 7, greater than 7. Alright, so the greater than or equal to, that's those numbers there. That's these numbers here. This is going to tell you that it's an or statement. Okay, so we have this one right here to the left says x minus 5 has to be smaller than or equal to negative 7. This one right here says x minus 5 has to be larger than or equal to positive 7. So you're going to draw your picture, then second, write inequalities. And then step 3, solve. So we're going to add 5, x has to be less than or equal to negative 2, or add 5, x has to be larger than or equal to 12. And that's how you solve these questions here. Alright, so this says less than 9. So before I draw my picture, what I want to do is I want to get the absolute value part by itself. So we need the distance from 0 has to be less than 6. So that's these numbers here, and that's these numbers here. That's an intersection. So when we do an intersection, we can write it as one compound statement. Okay, so we have to be smaller than 6 and it has to be greater than negative 6. And then you just go about solving like we've done in the compound inequalities section of the chapter. That was 6.4. Okay, and as you can see here, we're going to have some fractions. That's okay. I'm going to divide by negative 4, divide by negative 4, and divide by negative 4. I got to switch my signs. Okay, so, oops, I should actually switch them. Okay, let's see here. 1/4 is now larger than x, which is larger than negative 11/4. And since I like my values to go from least to greatest, I would switch this around so it looks like that. And that's your answer. Okay, and all these problems are pretty much the same. Basically, get the absolute value part by itself, then draw a picture, and then graph. So this is greater than 4, so 0, 4, negative 4, there, and there. So all the numbers that have a distance from 0 larger than 4, that's all of these numbers here that I drew on my graph. And then set up your 2, so this says x plus 3 is smaller than negative 4. That's this one right here to the left, and then to the right is x plus 3 is larger than positive 4, and then solve. And they're all pretty much done the same way. Just draw the picture, that will tell you if it's an and or an or statement. And then if it says is negative 5 the solution, you can just plug that in. Negative 2 times the absolute value of negative 4 plus 4 is less than or equal to 8. This is 4 times negative 2 is negative 8. Negative 8 plus 4 is less than or equal to 8. Negative 4 is less than or equal to 8. That's true. Yes, it is. So if they ask you if something is a solution, just plug it in and then see if it's true or not. Alright, there's the assignment. Thank you guys for tuning in to 6.6. Let me know if you guys have any questions.